Cool. Thanks, Luke. Thanks for the introduction. Hi, yeah, I'm Martin Costello. I'm a senior engineer at JustEatTakeaway.com and Microsoft MVP. Today, I'm going to be covering some things, some integration testing techniques for ASP.NET Core. In a previous life, before I was an engineer, I was a tester. So I've always sort of kept quality at heart. Like, stuff's not ready till it's tested, and you know it works. Like, testing's an open goal. Like, you can never test everything. There's just too many combinations, but it's all about using the techniques that you can come across to try and give you the high coverage and the high confidence that you can deploy changes that you need to fulfill business requirements and things like that whenever you can, whenever you need to, and not sort of be taking on too much risk or having to do that thing. Like, I'm sure we've all done this a few times in the past where it's like, ship it, oh, fix that, ship it, fix that. Oh yeah, missed that, fix that, and that sort of thing. So what I'm going to do today is this is mostly going to be me showing you some code in Visual Studio. I've got a couple of slides. I've got a few links to share at the end for the things I talk about. But this is mostly just going to be me talking through a solution that I've put up on GitHub. And I'm just going to show you what it's doing, why it's doing it, and what sort of benefits it can give you. I'll try and keep an eye on the chat, and if there's any ad hoc questions that have got quick answers while I'm going along, I'll try and answer them, but otherwise I'll try and cover questions at the end. As you can see, these are great slides. Design is my passion. So what do you mean by integration testing, you might be thinking? So as with all things in software engineering, there are many problems, and one of them is naming. So integration testing is, I'm going to talk about it in the way I think of it as. There might be other names this style of testing might take on, but this is how I'm going to refer to it during this talk. So to me, integration testing is a form of automated test, similar to unit tests. They're not unit tests in like the pure sense of you're testing a unit, but more they're like unit tests in you're using a framework like NUnit or MS Test, or in this case, it's going to be XUnit. So they're automated tests written with XUnit. They're not strictly unit tests, but they are automated tests. They're going to test the application from the outside as like a black or opaque box, as opposed to say white box or clear box testing, which is a term that's used within the software testing community. So on the whole, we're not going to be looking, with a few exceptions, which we'll cover. We don't really care about how it works internally, other than for setting up some of our tests. Instead, we're going to be treating the application a bit like how a real user would use the application to do whatever it is that application does. The exception to that is there's going to be a few things that we're going to stub out and mock, but they're going to be right on the edges of the application's boundaries. Like, we're not going to be like ripping out every other interface and replacing it with a mock, because we're not really testing the application then. We're testing that fakes we've put into the application work. So with the exception of the bits that I'll cover there to do with like the sort of the network connections at the edges, it's pretty much all going to be using the code that's in the app. That is what a user would do with the app if it was deployed. So the main things we're looking at to taking out from an integration testing point, though, is our external dependencies. So if you had like an external database like SQL Server, or you're using something in the cloud, I don't know, AWS, Azure, GCP, something like that, we take those parts out of the equation. It's like, in some ways, I think of these style of tests as if this was normal times and we could travel and get on planes and go wherever we wanted all the time, these are the sort of tests that you could run on your laptop with a network cable pulled out. Like, they would all run and they would all work, like if you were like in a Faraday cage. It's not quite true with this application because it's a web application, so all the JS isn't going to load if you're going to do that. Like, I'm not taking it to like the extreme, but that's the general principle of this type of test to me. And it's part of your inner developer feedback loop. It's like if you're adding new functionality to your application, you're running your automated tests, you can run them on your local machine, you're checking that the work you're doing is solving the problem correctly as whatever the requirements you're trying to do. And they're the sort of tests you would get before you get to the point of like opening a pull request, if that's the sort of workflow you use. They're not the tests that if you have like a quality professional who works with you, who looks at the developed artifacts after you've done your coding, it's the tests that you run yourself as part of your dev testing. You might even do it like a TDD style approach and write the test and then do the coding. Sometimes that's tricky if you're doing something from scratch because you have to write so many stubs before you can even get it to compile. But that's potentially a way you can write these tests, especially once you've got an initial framework written. It's a lot easier to just write some tests and know that they're all going to fail, and then you can go away and implement the business logic. So the main selling points of this style of testing, from my point of view, is that they validate the real application use cases. So it's not like the joke, a QA walks into a bar, he orders a drink, a lawnmower, he gets up on the bar, he throws the chairs around and all of that kind of stuff. When you're like going all the edge cases, you're concentrating on the value that the application itself has. So, I mean, in the case of the demo application today, it's all demos seem to be either a to-do app or a calculator. I've gone with the to-do app today. So it's going to be, can you add to-do items? Can you mark them as completed? Can you delete them when you're finished with them? And things like that, rather than does this method throw an exception when I give it null and things like that. They're not those types of tests. They're the sort of the tests that for the functionality that the end user has. We're not necessarily dealing, well, actually, we're not dealing with the classes in this style of test. Because we're looking at the whole application in this style of test, also means that it's relatively easy to get high code coverage on this sort of test, because if you were just doing unit tests, you've got like, I don't know, your data access layer, your service, your validator classes, and you test all those individually, but you're not testing that you set up your dependency container correctly. You're not testing that you didn't make any typos in your URL routing for your HTTP endpoints. You're not testing that you accidentally malformed some HTML and the page doesn't render correctly and you can't click the buttons, things like that. So you can cover a lot more with it with a lot less effort, in my opinion. It's also something I'm going to show as part of the demo. You can also build on this, so you can not just test you do like an in-memory server and just test ADPI endpoints. You can also extend it to actually expose and run the application like when you do F5 debugging. So that means in the case of a user interface application, you can also write tests that are exercising any client code you have. So in the case of the app I'm going to show you today, the client side in the web page is written with TypeScript. So I've not written any TypeScript tests. There's no unit tests or TypeScript specific tests in the app code base. All of the functionality for the UI is tested in .NET via the web tests that the integration tests use. So I'm very much mostly a .NET person. I can do some TypeScript and JavaScript. Don't let me anywhere near the CSS. But it's, for me as the developer, it's a lot. I feel a lot more confident and I'm more inclined to write more tests if I can write them all in a language I know, rather than this bit's in that, this bit's in that. Quality professionals might have different opinions on that and their own favorite tools, but from a sort of developer testing point of view, I think that's nice developer experience to be able to sort of keep within the same language and use all the tools I know to write the tests. And then the final sort of the selling point to like your manager or your product owner or whoever on why should we do all these things and invest all this time and set this up, is because it gives you the increased confidence that you can just ship something. So when they ask you to change something. You can change it. If it meets the requirement, the test's passed, you've got good coverage, then that sort of gives you the confidence to be able to just, I'm just going to deploy this change now. I'm just going to deploy this change now. Like, it's not always a good idea to maybe deploy on Fridays, but having lots of test coverage and things like that mean that it's, if you wanted to deploy code on a Friday, it's more a conversation of managing risk rather than, and being sensible rather than, oh, but you don't have any tests for this. How do you know it's just going to blow it all up when you deploy it? And that's all I've got in terms of slides. So now I'm going to switch over to Visual Studio. I've cranked up the font settings. I think they're big enough. Say something in the chat if for some reason they're not. Like, they're pretty big to me. But otherwise, I'm just going to step through the app and talk about the things it's doing. And I'm mostly going to be covering the test side rather than the app itself, because it's just a noddy to do app, really. I'm just going to drag it onto the screen, just show you it in when it's just running normally. So it's just a simple Bootstrap app. I'm in the wrong browser context. Excuse me a second. There we go. Having two Chrome profiles. So for the purposes of the demo, it's got GitHub authentication built in. So there's a question in the chat related to this. So this should cover that question while I'm doing the demo. So let's log me into GitHub. It's using my GitHub Enterprise, which I had to switch. So it's just a to-do app. I can buy milk, 2 slides for talk. I already did that. You've seen them. So don't need that. Delete it. And I bought milk. And then I'm done with that. I'm going to sign out. So that's pretty much all the app does. It's just for demo purposes. So this app started as a way for me to check that this style of tests would work correctly with the new ASP.NET Core minimal APIs. So that's what this is written in. I'm not really going to go into the specifics of minimal APIs today. There's a link at the end to some material about this. So I'm just going to skim over what the app does, and then we're going to go into the tests. So I've got a program class, and I'm just setting up my API. Like, I configured, I'll step into this in a second, set up the routes and the services for that, or services for that. I set up the GitHub authentication. I add Razor pages because the UI for the HTML, that's just a single Razor page. Then there's just some SwaggerGen stuff here that's not actually part of the demo, something for code spaces. And then I build the app, set up the error page, set up HTTP redirection, static files so I conserve the JavaScript and the CSS, configure authentication authorization, and then configure the API endpoints and Razor pages, and then run the app. And then I'll just quickly nip into these. So here we're just configuring GitHub authentication so that it knows what the endpoints are for the OAuth setup. And then there's a few endpoints to handle signing in and signing out. And then for the API, so the data store for this application is backed by Entity Framework, but it uses SQLite. So there's a database file disk where all the stuff's kept. So that's just configured and set up. And then we have the routes, and it's just setting up the get and post endpoints so that we can interact with our data model and return the JSON to the client side code to actually make the application add, remove, and edit the to-do items. And then, so there's a data section, data namespace, which has got where the so there's a wrapper, repository wrapper to the EF database, which creates the items, saves the changes, does all of those sort of things, and ensures the database exists. There's an EF context, which just stores the to-do items. some models. The single razor page, which is I'll just quickly open it. It's just the HTML for the app. All in here is the TypeScript that makes it work. I'm not going to go through the TypeScript code. And then there's like a simple service layer class, which just binds the API endpoints to the entity framework database stuff. So that's in a nutshell what the app does. So now we're going to go on to the testing parts. I should just close all tabs. So in the test project, so I'm going to step through this sort of, I'm going to go to a test and then I'll go off to some infrastructure that makes it work, then come back to the test. So these are XUnit tests. So I have a class called API tests. So this is testing like the add remove functionality over HTTP. So I have this class here, it's called a to-do app fixture. And what the to-do app fixture does is this subclass is this type called web application factory. This is a type that ships as part of the Microsoft ASP.NET Core MVC testing NuGet package. So it's part of ASP.NET Core, and it contains various functionality that lets you sort of bootstrap up a server, and you can access the service collection. So you can change the dependency setups if you need to. You can change the configuration if you need to. And if you're working with like a traditional MVC app, rather than say Razor pages, it also contains functionality to make sure that it can find all the Razor views and application parts and the dependencies and things like that. So what we're doing here is this fixture is deriving from Web Application Factory. And then this has got all the customization. So the tests themselves are quite clean, in inverted commas, and they've just got the tests in, and don't worry about what needs to happen to have the server set up. And then that means there's lots of reuse in the tests if you had lots of tests testing this application. So when we set this up, we just configure it to use HTTPS. That's mainly to keep Chrome happy from and also because the app by default does HTTPS redirection, because that's what you would do in production these days. And rather than have to have lots of if tests do this, if prod do that code, because then you're not testing the production branches, you're testing the test branches. So it's not as realistic. So in this case, the app's set up to also use HTTPS. Then there's a class here, which we'll come to in a minute, HTTP client interceptor options. There's a library that I wrote a few years ago now. That we use this extensively inside Just Eat for integration testing. What this does is it's a NuGet package, Just Eat.http client interception. It's a way of setting up HTTP requests that hook into HTTP clients. So some of you might have in the past done the pattern where you sort of wrap HTTP client in an interface, and then you create mocks for the interface of the HTTP client so you can test things. Then you have to deal with HTTP request objects and HTTP response objects and all of that kind of stuff. This library sort of encapsulates all of that and does it for you with like a builder pattern on top. So you can say, when you get a GET request for this URL, do this. Or if you get a POST request for this, do that, or return this error. So you can do error cases as well. So if you use an app like Poly, and you are doing things like circuit breakers, retries, timeouts, things like that, you can also configure the error cases for those. So then you can test that your retries actually retry and things like that without lots of low-level unit tests necessarily. So we're setting that up and making that available on the fixture, which we're going to use in a minute. Also, test output helper in XUnit is what's used for logging to the XUnit test output. So I've also written a library, I'll stop plugging my own stuff soon, that creates a bridge between the iLogger interfaces of .NET Core with XUnit. So what this does is it allows you to have the web server that we're going to run as part of this integration test send its logs to the XUnit output. So then that means if the XUnit test, the XUnit test fail, like you break something, you can look at the server logs and go, oh, there was an unhandled exception, null reference exception in this class, and then you can sort of go and diagnose what you've broken and fix the test, rather than just, oh, the black box failed, or oh, it failed, I'll go and try and find the logs of where it logged onto disk somewhere. So it's a lot more portable and maintainable and easy to use, routing them through to XUnit than trying to find files on disk, especially if you're using a CI environment, because you can't just go and look at the files on disk in someone else's hosted server. So the important bit of this, the bit of this class, I wasn't sure if there was a bit more after I finished scrolling. So here, overriding this protected method of the web application factory class, configure web host. So what we can do here is we can tweak the configuration of the server to serve our need to run it as part of tests. So what we can do here is we can tell the SQLite database to not go in the app data folder, but to go into a random temporary directory on the local machine. So the benefit of that is it means test runs don't have to worry about tidying up the database, worrying that maybe a previous test or your local debugging has left things in it and might break your test setup. So it's every time it's a fresh application. So that's configuring the data directory, and then we're also configuring our GitHub OAuth integration to have this special quotes GitHub ID and GitHub secret, and also just turning off the enterprise domain I have configured in my user secrets. And then we add that to the configuration of the application as well. And because we're adding that sort of last, that's sort of overriding whatever is set up in my debugging setup for the application. Then we change the logging configuration. So I'm just going to remove any loggers that were already there. So console, files, whatever it might be, they're all gone. And then instead, we're just going to route all the logs to XUnit. Then we just need to give it a hint to where all the static content for the app works, because when you run these tests, they're all running over in your like test bin area, and they're not going to have like the TypeScript files and the CSS files. So you just have to tell the test server where they are so that it can load them up. Because otherwise, if you run any UI tests, then it's all going to fail because none of the JavaScript files from the TypeScript compilation are going to be there. And then this is sort of the magic bit, and this should answer the question about third-party integration. So what I'm doing here is I'm adding HTTP client factory into the application, which is an interface that's available in the .NET Core extensions. And then there's a little bit of it saying ASP.NET Core as well. It sort of sits in the middle between the two. So I'm configuring that so that I can put a HTTP client in DI. Then I've got this little class which implements a very Java-esque interface name, iHTTP message handler builder filter. And I give it the HTTP interception options that were set in the constructor that's a property of the fixture. So I just step into here. Whoops. No, I didn't mean to step into there. I mean to step into there. So what this does in a nutshell, I'm not going to go into all the specifics, is this sets up a hook so that when the application requests a HTTP client through DI, this code will run. And what we can do instead is we can make as part of the HTTP request pipeline. So this is like where, so you start at HTTP client level and you go to the HTTP client handler, and then there might be a redirect handler and a cookie handler and an auth handler and a logging handler, etc. It's HTTP delegate handlers all the way down. And what this does is right at the end of the chain, it pops in HTTP message handler that's associated with the HTTP client interception options. that gives as a whole, it gives our test an opportunity to listen to all the outgoing HTTP requests and go, actually, I don't want you to go over the network for this one. I want you to return this instead. And then that's the bit that breaks and not breaks. That's the bit that makes it work if we were hypothetically going to pull out the network cable. So that means when it goes out to GitHub to do the OAuth dance to log into the app, actually we can go, oh, here you go, here's the response. There it is, you don't need to go over there. So that's what the filter does. And then there's two more bits for this. So have a name I've arbitrarily picked, remote authorization events filter, which is an iPost configure options of the GitHub OAuth options. So we put that into DI as well, so that this will run as part of the application startup. And what this class does is it just tweaks the OAuth settings. So it configures the back channel property on the OAuth options. So at this point, we're saying to the OAuth authentication infrastructure, when you need a HTTP client, use this, please, not whatever you would have done normally. And because we're getting the client, the HTTP client from the HTTP client factory, which is in DI, that means it's getting the HTTP interception hooks pulled in with it. So the OAuth infrastructure will be using a HTTP client that's associated with our test setup to sort of intercept the network calls. And then finally, there's this property called events type. So as part of how OAuth works in ASP.NET Core, there's a number of events that fire when the various parts of the OAuth flow happen. What we're doing is we're just hooking in a custom type for that to give us a hook to do one more thing. So I don't need that anymore. So then now we've got a class called loopback OAuth events. So this is the bit that makes the login really work. So like if you were normally doing the OAuth flow, you'd click the sign in button and it would send you off to GitHub. You'd have to fill in your username and your password. And then if you'd set up 2FA, then you'd have to do your 2FA codes as well, which would be very difficult in an automated test on a build server to deal with. And then when GitHub was happy that you'd authenticated, it would then send some information back to your app and redirect the user. And then that would complete the login flow and give it a token for it to do some back-end callbacks to sort of finalize the authentication. But because we've got this hook here for the redirect authorization endpoint, instead, what we can do is just before the OAuth part of the system tells the app to redirect off to GitHub, we can actually just point it back at itself and then just go, hey, here you go. Sure, I talked to GitHub. Here's all the data you need. And what we're doing here is we're just stripping the redirect URI and the state parameter, which is used to like validate that the call back to the originating request for the login. And then we add in a few other parameters that the OAuth setup expects, and then we just send the app. So we send the browser back to the app itself. So from the app's point of view, you did go off to GitHub and sign in, and then we're continuing the flow. So we're actually skipping a step of the flow. But that means from a test point of view, you don't have to automate the login screen anymore. You can just come back and just be logged straight in. And then the final piece of the test setup before we go back to the test is a feature of the HTTP interception library is it supports something called what I've called bundles. The primary model that it uses is like a builder pattern. You write the requests in code, and it also lets you to do like dynamic callbacks to change the responses and things like that. But in the case of this app, it's all the responses are fixed. So it's easier, in my opinion, to just put them in a JSON file and just have it read them and deal with them that way. So in this bundle file of JSON here, I've just configured what should happen when the app calls the GitHub token endpoint. So it returns this JSON. When it asks for the information about the user, once it's got the token, it returns this JSON. And when it asks GitHub for the user's email, it returns this JSON. So we don't actually need any real setup with GitHub here to use it. So we just register that bundle here with the interceptor. So that means whenever whenever HTTP requests configured in the bundle are requested by the application, the interception code will instead return the responses as configured in the bundle file rather than actually making the network calls. And there's an option on that throws on missing registration. You can set the interception code up so that if it can't find any registrations that you've put in, it'll throw an exception and make it fail. That's useful if you have a large suite with lots of tests set up. It can be easy to accidentally forget to set up some of the requests. So in those cases, if you just make it fail, then it helps drive you towards more reliable tests because you don't have tests that accidentally pass and then a week later something changes and then they're broken and you're like, oh, I forgot to do that. It's sort of a safety net against that sort of thing that can lead to test rot over time. So that's what the fixture does. Didn't even show you what the test does. So we've got our tests which take the fixture. So that's effectively an in-memory server that has set up the app with a few modifications so that we don't need to worry about real GitHub and we can have the SQLite database be in a random location every time we run the tests. So now we've got our API test here. So I'll go to this method in a second. So we get a HTTP client that's authenticated. And then at this point, this is pretty much just bog standard code you sort of know from unit testing. We're just doing GET requests for some plain old CLR objects, POCOs, to the API's endpoints. And then I'm using an assertion library here called shouldly to do the asserts that. So if I call items, then it shouldn't give me null and that shouldn't be null. And I should have however many items there are. And then I want to buy eggs. So I post buy eggs, check assert that it was created, and then get that item and check that it did indeed go in and say buy eggs and there's not a bug and it said nothing or something like that. And then it just sort of steps through what the API does. It like adds items, it completes them, it adds some more, it deletes them, and it just asserts that the API behaves in the way you would expect. And it's not just the positive cases it can cover, it can also do your negative testing. So here it's just doing a few tests to test that if invalid items are rejected and you can't complete an item twice and what happens if the item you asked for doesn't exist and things like that. But yeah, so to go back to the create authenticated client async, what that does is it calls the create client method, which is built into Web Application Factory, and sets it up with auto redirects to point to the base address associated with the server, and it's configured to handle cookies. And then what it does is it does a post to the sign-in endpoint with the form, which is what the browser would do if the user clicks on the login button. But because we've got auto redirects turned on and we're handling cookies, what happens is it calls the sign-in endpoint. The sign-in endpoint goes, oh, I need to redirect you to GitHub. The redirect tries to go after GitHub, but then the tests send it back. And then that'll give it like the state and what have you. And then the app will go, oh, great, you're logged in. And it will return the authentication cookie. And because we're telling the HTTP client to have cookies handled via this option, that means this HTTP client now has an authentication cookie associated with it. So then that means that all these other tests that we have, they all authenticate and authorize successfully because every request to the HTTP endpoints is taking the auth cookie with it like it would if the user was logged in the browser. So without having to do any UI code to log into a browser somewhere, we can just go, yeah, we're logged in, it's all fine, and then test the business logic. So this is all using our to-do app fixture, which just inherits from Web Application Factory. But what if we want to test the UI? This is all in memory. It's not really listening on a HTTP port. how are we going to automate that if we can't get to the app? So for our UI tests, we have a slightly different class now, HTTP server fixture. And what HTTP server fixture does, this inherits from the to-do app fixture class, but it does a few more tweaks. So it exposes a property to get the server address, and it also overrides the service provider that is exposed by the base class and changes it to the one associated with this iHost. And whenever the properties are accessed, it tries to make sure the server's running. So here we've got another configure web host override. So we call the base class, so that does all our OAuth setup and all of that stuff. But it does two extra things. First, it configures Kestrel so that it has a TLS certificate so that we can have it run on a HTTPS endpoint on a port. And then it also calls use URLs. And instead of whatever the default is, say port 5000 on HTTP, instead we're saying use localhost. And then this bit here, this bit means on any port you can find that is free. So that means you don't have to write code to try and enumerate the free ports on your machine, because that's another source of test flakiness. It's like, oh, I couldn't start the server, this port was in use, or something like that. So by saying 0, you can just go, yeah, fine, just find a port, whatever. Of course, that means that you don't know what the port is, but we'll come to that in a minute. So then is it the final? Yeah, the final piece of the puzzle that's worth talking about is that I now override this create host method. So this is the bit in the base class that creates the test server. But what we want to do is we want to sort of do a bit of trickery and swap it out. And instead of having a test server, we want to use a real server. So that's what this method does. So there's a few quirks in the ordering here for ASP.NET Core 6 and minimal APIs for me to work around some behavioral changes. So there's two bits that look a bit odd, but that's me working around some things the base class does that interferes with this style. It still works, but it's not designed for this. And I've built a lot of test infrastructure on top of this now, so I want it to keep working. So I just build the test host before, because we've got this builder that the base class has given us, and we need to use it later just to make the base class happy, or the caller of this method happy. So I need to build it and sort of save that away before we do any changes. So now, if we didn't do anything, this host builder is configured with use test server, but we don't want to use the test server, we want to use a real server. So instead, we call use Kestrel on it. And now we're going, no, HTTP server, please. And at that point, we can then build the host and start the server. And then at this point, we've now got an app, a host ready to run that could accept HTTP requests. But we said port 0 before, so how do we know where to send the browser? Well, what you can do is you can access the service collection of the host to get the iServer, and then the iServer has a features collection, and then you can query the feature collection for the iServer addresses feature, and that has a property on it called addresses, and that gives you the URL of every address that the application is listening to. So if you did, when you're doing like F5 debugging, by default, it'll be on HTTP port 5000 and HTTPS port 5001. Whereas in this case, it's going to be on localhost 127.0.0.1 something. And we don't really care what it is either, because we're just going to go through the addresses and just take the last one and store it in this client options.base address. The reason we're putting it there is because the calls to create a HTTP client, they get the address to configure on the HTTP client from there. So if you put the address there, all of the out-of-the-box HTTP client functionality on the Web Application Factory class will just work. And then finally, the last little quirk is because the base class is expecting there to be a test server, not a real server, and there's a cast somewhere that like requires that, and if it's not, it will just blow up and break everything. So that's why we built the host at the top, just so we can start the test server as well and give it to the base class. It will never actually get used by these tests, but it's just there, keeping like the base class's contract happy. And then dispose is just overridden just to make sure we shut the server down when we're disposing. And then the ensure server method that was at the top of the class, whenever that's called, it just calls calls create default client, which creates a default HTTP client. We don't actually need to use it, but doing that the first time the web application factory class is used makes all the code paths that result in these two methods be called. So by doing one throwaway create HTTP client call at the start, that'll bootstrap up the server and get everything set up for us. So now if we go back to the UI tests, always skipped over this in the other class, it's the same here. Every time you run a class in XUnit, each individual test has its own test output helper. There isn't like a single one for the whole test run. So every time a test runs, we have to get the test output helper and associate it with the fixture. And then when the test is torn down, it deassociates the fixture. And that's the bit that makes the logging work. I've got some test cases here. So I'm using an XUnit theory, and I've got a bunch of different browsers that I can run. I can do Chromium, I can do Chrome. The time I wrote this, Edge didn't work on Linux, so it doesn't do Edge on Linux. Firefox, and if it's Mac OS, it can do WebKit as well. And so then I'll go into this in a second. So I've got a browser fixture, and then with the browser fixture, I go, please give me a page. And then with that page, give it to me and I'll run a test. So with page async gives me an iPage, which I'll come to in a minute. And then I can go to the server address, wait for the DOM to load. Then I've got a class called to-do page, which is like page object model. So that's my encapsulation of all the selector logic for how to manipulate the web pages. And then I can sign in, wait to be signed in, check that the username is John Smith, wait for there to be no items in the list. Let's buy cheese. Does the UI say buy cheese? Then we'll buy eggs. Does the UI now have buy cheese and buy eggs? I then delete cheese, complete eggs. So now we're just left with eggs. And then we delete the eggs. There should be no items left. And then we sign out. So I will run the test just to show you it. And then I'll go into the browser fixture bit. So just need to try and catch the browser window when it opens on the wrong screen so I can drag it in so you can see it. There we go. And that's it. So with the test, the self-hosted server, we're just testing the whole application stack with one test there, which is why I was saying that it can potentially give you very good code coverage. We'll come to that in a few minutes, getting near to time. So the UI testing for this, I noticed somewhere in the chat, someone talked about Selenium. This is not using Selenium. This is using a newer web application testing framework I learned about this year called Playwright. So if I go into browser fixture, so this is using Playwright, and compared to Selenium, which I think has not kept up with the .NET idioms over time, like it's perfectly capable at what it does, but in terms of the .NET bindings, I think it's kind of stuck in the .NET 3 era, whereas Playwright is sort of quite idiomatic for modern .NET, and like almost every method on it is async. And in my opinion, it also has very good support for like implicit waits. So you don't have lots of flaky UI logic, like click the button. No, the button wasn't there yet. Don't click yet, it's too early. It will sort of wait a little bit and then it'll click it, and other sensible conventions like that. So I think it's very neat and tidy for that sort of thing. One downside of it is, as far as I'm aware, it isn't currently capable of or possible to extend it to use tools like Browser Stack. So So that's the one shortcoming of it. But for like personal hobby projects or things where you don't have or need that, I think it's a very good alternative to using Selenium. So what this browser fixture does, I've just encapsulated away all the browser setup fixture stuff. So I create a Playwright instance, then I ask it to create me a browser, then I ask the browser to create me a page, then I wire up the console and page error events to the XUnit output helper. So if the test were to fail with the JavaScript error, it would be reported into the test output. So you don't necessarily have to debug it and look at the Chrome developer tools to work out why your test's failing. You might be able to just go, oh, yeah, there's no event called that. That's a mistake. Whoops, and fix it. And then once it's done all of that setup, it just calls the action that's passed in. So that was the body of my UI test there. And then if an exception happens, it will try and take a screenshot. And if it was recording a video, which is another nice built-in thing with Playwright, it can record videos for you, which is great for tests that fail and you can't work out why they are, because you can just watch them back and go, that's what went wrong. So you create a page, you can give it a time zone and a language. We just have to tell it to ignore HTTPS errors because the test server is using a self-signed TLS certificate. It's not a real valid one. That's mainly because it's checked in with the code and it's public on GitHub. I'm going to put a real certificate in there. And then if the record video property is true, it sets a directory to save videos to, and then it will automatically record videos for you. And then when we create a browser, if the debugger is attached, which it was when I just showed you the test running, you can tell it to show the dev tools, so you can see the console and you can use the web inspector. You tell it not to be headless, so you can see it. And there's also this set property called slow-mo, and you can tell it to run slower than it would if you were just running the test normally. And then that means you can watch what it's doing, which is why the typing was like buy eggs, because it's slowed down. But you don't have to do that if the debugger's not attached. The tests run a lot faster. And then it just tells it which browser to use. And then there's a bit of boilerplate code to generate unique file names, and then save the screenshots somewhere and try and save the videos somewhere. So then I have that set up because this repo uses GitHub Actions for CI. So if it's running in GitHub Actions, it records the videos. If it's running locally by default, it doesn't, because I don't want my hard drive filling up with videos every time I run the test. So that was that. And just quickly go to the page object model. And yeah, this is encapsulating all the code of actually manipulating the DOM to do the clicking the buttons and typing and things like that. And I'm not really going to go into the specifics. So you can like wait for selectors, you can get the inner text, you can click things. And then I have another class that encapsulate the individual to-do items, so you can complete them and delete them and get the text of them. And then you can just do simple selectors like this. So for the add item button, I just find the item with this ID. For the text of an individual item, just give me the element that has this class. So you can use whatever conventions you want to do your test selectors. You can use attributes, you can use class names. You can put IDs on everything. But so the test is just using the application. It's quite simple to read the test and go, oh, I'm adding an item, I'm deleting an item, I'm completing an item. And all of the logic to actually know how to find those on the page and interact with the DOM are all just hidden away in this private selectors class here inside the page object model. So then the final, actually two final things I'm going to show you. So I'll just put this back. So if I open the test log, so when I ran that test before, this is showing the server logs. They've been output to XUnit, so I can read them. So you can see when I ran the test, it was on port 49,200. It tried to sign into GitHub, which it was challenged, and then the rest of the test ran. It hasn't logged anything else because I've got the log level on quite low, but it logged in and worked. We watched the browser do that. And then finally, for code coverage, it's not set up in the IDE, but I'm using a package called coverlet.msbuild. And what this does is it hooks into the .NET test command. So you can do code coverage when you run .NET test. So I'm going to show you that there. So I just have a couple of MS Build properties. So I tell it to collect code coverage and the format I want it to be output in. So then if I go over here and I just do .NET test, just take a few seconds to build it and run all the tests. Drum roll. Should have come up with jokes for the awkward silence while I wait for this to finish running. There we go. Test will run. That was, where's the time? I thought I used to have a time. Never mind. Oh, there it goes. 15 seconds. So it took 15 seconds to run all of the tests, including the UI test. And we've got 91% of all lines of code have been covered, 81% of all code branches have been covered, and 92% of all methods have been covered. And then the final bit that I'd actually forgotten I need to show is this is also, it won't be from this run, it'll be from a different command I ran earlier, but I'm also using something called report generator, which can parse, I forget if it's the JSON or the Code output format, but this can generate me a code coverage report. So if I open index.html, I can get a nice HTML report that shows me what has been covered and what hasn't been covered. So green is covered, yellow is partially covered because this is a branch. It's only done half of the branch because it's an if. And because this is all red, it isn't covered. So that means it's covered the if false branch, but not the is true branch. And then you can go through your reports for anywhere that's red and potentially expand your tests to cover all the bits you haven't done. So to sort of go back to the points I was making near the top of the presentation, was that we've got 9 tests and we've covered 90% of the application, and 4 of those tests are just running the same test in 4 browsers. So really it's 6 tests. So in just 6 tests, we've integration tested our whole app, and including HTTP calls out, OAuth integration, and our TypeScript and HTML code, and it's all been written in .NET. That's what I think the power of the integration tests, as I'm calling it here, approach is. You can do very high level tests and cover a lot of your code. Once you've got all the plumbing of like your HTTP fixture and your browser fixture and things like that written once, then it's just a case of, oh, I want a delete all button for all of my to-do items. Great, we'll just add the HTML for that. We'll wire up the TypeScript to that. We'll add the endpoint that iterates through the database and deletes all the items. And then we'll just add a test. We'll just either extend the test we have or add another test. If I click the delete all button, is the table now empty? And we've already written the methods that check for the table being empty. So you can add new functionality and test it and be confident that it's working with minimal additional effort once you've done the initial sort of test setup. And that's my selling point of it. And now I've just got a slide that says questions. I appreciate I've run over slightly, but I'll hang around for questions. And just before we start the questions, I've sent Luke the link to these slides, and there's the links to everything that I've sort of shown are here. There's more links in the GitHub repos README file, and when I mentioned earlier, it's all based on minimal APIs. There's also a link to the latest documentation by David Fowler on the ASP.NET Core team, which explains how those work if you haven't seen them before and got a bit lost by how the app itself is implemented rather than the tests part. So yeah, time for questions.
Yeah, cheers, Ryan. That was that was great. I think you were kind of answering questions a lot like ad hoc throughout the session. So now we get to this point, I feel like you might have answered everything, unless, of course, as he's requested, if there's anyone else with anything to say, if you speak now or forever hold your food. I don't know.
Just going to skim the question chat now. So, I scrolled under me. So Raj Karwal asked, how do you integrate with an external auth system? Feel free to ask if I didn't cover that, but I think I covered that with the GitHub example. Rick asked the purpose of the to-do app. Oh, hey Adam. Adam answered that question for me. Yeah, it's that's adding as application under test specific behaviors on top of the web application factory. So they're all in a central place rather than us having to do it in the tests themselves and potentially repeat ourselves if we have lots of different tests. The repo. So yeah, Raj asked again about, do you have to use Selenium? We use Playwright here, so no, you don't have to use Selenium. And yeah, that's all the questions that
But there's a new one which has just come in from Sapphire.
Yeah, there we go. How stable have you found running Playwright? So I have in other projects, I have had a few times where like I've had flaky tests. I think actually there's I didn't call it out, but there is one single. Let's just randomly wait for half a second here, and that's because sometimes the test was running before the client had finished repainting the screen. So the items that had been deleted hadn't been deleted from the DOM yet, so the count was wrong. So it does happen occasionally, not too often. I think it's probably mostly a function of how complicated your UI is. I think if you had a very complicated, very interactive UI, it would maybe start getting similar to Selenium, where you have to do your like weights and your retries and things like that. But in most cases I've used it for, which admittedly they aren't really complicated like React Native apps or anything like that, I find it to be in general more reliable than Selenium for doing things, and definitely a lot faster.
Yeah, unless there's anything else. No. But I mean, if that is the last question, then obviously thank you to everyone who's stayed until this point, and then thank you again to Martin. I know you're quite active on GitHub, posting all the time, but I know you're reachable via Twitter. I think that's Martin_Costello.
Yep.
On LinkedIn as well. And then, as Martin said, I'll have he shared these slides with me, which of course got some links for you guys to follow through. So yeah, I'll share that. I will share that along with the link to our Slack channel. So join on there if you'd like to receive the slides. Yeah, guys, thanks. We've got another one in 2 weeks, as I mentioned, with David